AI. But the most fundamental point about all of this artificial intelligence is to be able to feed back the information into the data model to actually effect the change. I think without this, it's actually a complete waste of time. So I wanted to take a moment just to talk about my thoughts on AI, specifically for discrete manufacturing. There's obviously been a lot of hype around the topic of AI. I think AI POCs in manufacturing have been going on for a long time, but a number of them haven't really realized the outcomes as expected. And I'd like to talk through some of those outcomes and my thoughts on how I think we need to be dealing with AI in manufacturing. So as I mentioned, I just want to focus in on discrete manufacturing for today's discussion. So according to a recent PwC presentation that I was part of, I think everybody understands there's massive opportunities for increased efficiencies, quality improvement, predictive maintenance, and predictive quality, and I guess predictive everything, as well as supply chain optimizations by applying AI in manufacturing. In the presentation, they further spoke about the trillions of dollars that can be gained by applying AI in manufacturing, really around labor productivity, personalization, time saved, and obviously quality. So I think everyone buys into the opportunity, but what I wanted to get into today was a little bit about why it hasn't been successful, and maybe more importantly, how I think we can do it to be successful. So just to take a step back, I think the first point that I want to highlight is that in developing a smart manufacturing assembly line for discrete manufacturing, we need to think of it as digital first. So you need to start out with a digital infrastructure layer, which includes some hardware elements like servers, networking, data management, obviously security, and services like a data model structure that's already been developed and planned out from the beginning, not a fixed data model, but a dynamic data model that can actually adjust to different requirements on the shop floor. And then obviously we have different types of machines, manual machines, automatic machines. Bolting equipment is a big part in discrete manufacturing, as well as press force, press fit. And obviously we have semi-automated machines. This is where a human is actually interacting with the machine. And one of the key principles of your digital infrastructure, it has to be supplier agnostic. So you need to be able to get a machine from supplier X or supplier Y and interchange these machines as and when your product and your demand, your volume demand requires. Within this digital infrastructure service, we need to have a couple of functions that need to be taken care of. And some of them are pretty obvious, like your variant management or your recipe management, your bill of materials management. You need a place to determine your process of assembly, your process of operations, your parameters, your press forces, tightening torques, all of that kind of information needs to be set up in an environment that forms part of this digital model that I spoke about. In the cases where you have manual stations, you need to have a centralized place to set up all of your digital work instructions, connect the hardware that validates the processes are done by the operator. And then obviously we need the tracking and traceability and the data handling of all of this process. So as the part moves from one station to another, we record the key quality measures, we record cycle time and sort of productivity information. All of that data tracking and recording and handling obviously needs to be handled by this digital infrastructure. And this is the concept of data-driven assembly. And I'll get to why this is really important a little bit later when we touch on the AI topic. But data-driven assembly is fundamental if we want to take advantage of AI in the future. Another critical part that I think is often forgotten about is the communication layer between the machines on the shop floor and this digital infrastructure. We have many communication protocols protocols, Profinet, Profibus, obviously Ethernet IP, we've got OPC UA, MQTT, and a lot of those have served us well for a long time. But I think that we need a much lighter weight, bidirectional, transactional communication protocol that's designed to be efficient. So some of the shortcomings, for example, of OPC is really heavy on the hardware, and so you have to beef up the hardware, which costs a lot of money. It can't run on, or it struggles to run on microprocessors, for example. And so you need a lightweight, transactional, fast communication protocol to manage the interaction between the machine and this digital infrastructure. Obviously, we have built-in functions that are required, for example, moving a product from station A to B, or 20 to 30, 30 to 40. We have rework and exceptional management that is really critical in this digital infrastructure. So when things go wrong, it's really important that we manage that in a very controlled and structured way, because this is one of the biggest reasons why we have recall campaigns, especially in the automotive industry, is that we don't manage our reworks and our exceptions correctly. You obviously need interfaces to existing systems. So this digital infrastructure needs to be open, needs to be built with an open architecture so that other systems can interact with it. So sending down a bill of materials, for example, sending down a queue to the queue of the product that needs to be built, or passing information from the digital infrastructure to higher ERP systems, for example, for business purposes and calculating financial costs of your production line. And then obviously we have reporting and analytics. This is kind of obvious. And one of the fundamental parts of these communication protocols that I've been speaking about. So we developed one called ODEX, is to be able to get the granular data from the machines so that your reporting can be actually in enough granular information for you to make the right decisions. So having high-level reporting doesn't really make sense, because it doesn't help you fault find and understand exactly where the problems come from. And then sitting on top of this is what I call the artificial intelligence service. And I think this is an important point to highlight, is that artificial intelligence on the shop floor and in factories is actually a service. It is not an outcome. You don't make a production line to output artificial intelligence. Artificial intelligence is actually a service that runs, that is used to provide information of possible opportunities and risks on your shop floor. So it's actually something that runs in the background, and it needs to be designed in such a way. It's not an outcome. It's actually a service that optimizes these existing processes that happen. So it's not like we introduce a new process onto the shop floor because of artificial intelligence. Artificial intelligence helps us optimize these processes and systems and manage our risk, predict failures. So within the artificial intelligence service, we have different types of artificial intelligence. So obviously anomaly detection, prescriptive manufacturing, which is where we decide on better machine parameters. So for example, if there's a tightening operation or a bolting operation that happens over here, and we recognize there's a lot of failures, could we determine that maybe slowing the bolting tool down will improve the output? So the prescriptive manufacturing would determine the settings that are required for that bolting tool to improve the output. And then we have generative and conversational AI, where we are enabling sort of automatic generation of work instructions, for example, and having multiple people communicate with the production line in a human way. So this is the idea of conversational AI. But the most fundamental point about all of this artificial intelligence is to be able to feed back the information into the data model to actually effect the change. I think without this, it's actually a complete waste of time. If you do not give the data back to the production line to actually effect the change, then what's the point of artificial intelligence? And this is why designing your data infrastructure and your digital infrastructure right from the beginning is so fundamental to actually taking advantage of artificial intelligence. You cannot take it from a top-down approach. You have to take it from a bottom-up approach. And for me, this is why a lot of the existing POCs in the world have not yielded the outcomes as expected, is because they come from the top down. I think you have to take a bottom-up approach, which is much harder, but I think the right way to actually handle artificial intelligence on the shop floor.